So we left off at this, we had finished the first problem 5. We were about to start on the second problem 5, and this is where I stopped on Friday. So we have a geometric sequence. The numbers are 6, 12, 24, 48. How do we know it's geometric? What's happening every time? You're multiplying by 2. So to get from 6 to 12, you multiply by 2, 12 to 24, you multiply by 2, 24 to 48, you multiply by 2. So that's what makes it geometric, is that you are multiplying by something every time. And then if we were to fill in our table, the left side asks for the position. That's like which term in the pattern is it. So my first term in the pattern is what? Yes, and my second term is, and my third term is, and my fourth term is. Okay, and I could keep going, couldn't I? Okay, if I wanted the 50th term in this pattern, okay, if I wanted the 50th term in this pattern, would you really want to keep going? No. So we're going to learn today about a formula that we can write that can help us find the 50th term. Yeah, we're going to talk about that. Now, if I just wanted the 6th term, would that be okay to keep going? Yeah, because that's reasonable. To ask you to multiply by 2 more times, like, you can handle that. But to get there 50 times, like, that's absurd. Okay, so we're going to learn a formula that will help us figure that out. Let's look at our graph over here to the right. We're actually going to graph this. So on the x-axis, I'm going to label it by 1s. How do you think I should scale my y-axis? And make this easy for yourself. Okay, what else? Multiples of 6 would be a really great one. 10 is not a terrible one, but if I can do multiples of 6, why not? Because I can make my scale whatever I want, and all of these numbers are divisible by 6, so that would be like, as far as making it easy on yourself, that would be the easiest. So this would be 6, 12, 18, 24, 30, 36, 42, and I'm going to stop at 48 because that's where our table stops at. What was our first point there? 1 and 6. Okay, so I'm going to put a point at 1 and 6. All right, what was our next point? 2, 12. Okay, our next point? 3 and 24. And then our fourth point? Okay. If I were to connect these, what kind of shape would that make? Okay, it'd be something like, it'd be parabolic looking, like half a parabola. It's actually an exponential function is what it is. So if I were to connect it, it would look, ooh, let me not use that pen. Let's use this one. If I were to connect it, it would look something like that. And this is called an exponential function. Like this shape right here is an exponential function. You have 2 formulas that I'm going to teach you today. And those 2 formulas are going to help you. Depends on what information you need, which formula you use. Let's start with the recursive formula. What does the word recursive mean, or recur? Yes, it happens again and again and again and again and again. Well, isn't these problems, aren't they recursive problems? Why? Yeah, you're multiplying by the same thing over and over and over and over and over again. So this is a recurring pattern. It's a recursive sequence. So the formula for recursive is A sub n equals A sub n minus 1 times R. A sub n equals A sub n minus 1 times R. I'm going to put this into words because some of you are like, what does all this stuff mean? There's a lot of letters there. Okay, so all this means is that to find some number in the pattern, or to find any number in the pattern, you need to take the previous number and multiply it by R. When we talk about a n minus 1, that just means the number right before the one we want. I'm going to put this into an example in a second. Okay, so I'm going to apply this problem, this formula we just learned, to problem 5. So for problem 5, which is on the front side of the notes, that would be an, so some term in the pattern. To find it, I need to know what the previous term is, and I need to multiply that by, what was our common ratio on this problem? 2. So let's suppose that I wanted to find the 11th term. Okay, talk me through, just without using this formula, talk me through how you would find the 11th term given the information that you have. But do we know the 10th term? So what do I have to find first? Which terms do I know? I know the 4th one, so what would I have to find first? The 5th. But how do I find the 5th term? I multiply the 4th term by 2. And then to find the 6th term, what would I do? 5th term by 2. So every time I'm multiplying the one before it by 2, right? That's what all this formula says. Is that to find some term in the pattern, I multiply the one right before it by 2. So if I want the 11th term, then I need to find the a sub 11 minus 1 term times 2. What's 11 minus 1? 10. So this is saying that to find the 11th term, I have to know what the 10th term is, and then I can multiply that by 2. Because that's what we multiplied by on this problem. Like 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Okay. Yeah. So in this problem, our common ratio was 2. So Reese, that was what you were asking is what is R? R is what you're multiplying by every time, our common ratio. Okay. Well, do I know the 10th term here? No. So I'd have to go back and find the 9th. I'd have to go back and find the 8th. I'd have to go back and find the 7th. This is called a recursive formula, and this is just telling you that to find a number in the pattern, you multiply the one right before it by 2. That's all this is telling you. Now, this formula is complicated because we don't want to do that. That's a lot of work. So that's where the explicit formula comes in, the other formula, and that's going to help us find any number in the pattern that we want. So the other formula, which is called the explicit formula, it will just automatically find any number we want. Like if we wanted the 100th number in the pattern, we could use the explicit formula. Now, I'm not going to ask you for the 100th number because just so you know, these numbers are going to get really big really quickly because you're multiplying by something, and that's going to continue to get larger and larger and larger. So for the explicit formula, there's 2, and we're going to talk about how you know which one to use, and they're literally the same formula. It just depends on which information you're given, which one you use. So the first one is the formula a sub n. So to find any term in the pattern, you take a1. What is a1? The first term, whatever the first term is, times r. What is r? Common ratio, whatever that is, to the n minus 1 power. And that's our formula. So it's the first term times the common ratio to the n minus 1 power. That's our equation.
So in short, isn't it just putting an exponent like to the power of how many you're trying to find?
Yeah, except minus 1. Because you're starting at the first number. Like you're starting at 1 instead of starting at 0. So you have to subtract 1 to go back. Does that make sense? Okay. So the other option, the other formula, and this literally, like I said, it just depends on what you're given. The other formula would be a sub n equals a sub 0. Because sometimes on some of the problems that you have today, you're given a0. You're given term 0. Sometimes they start at term 1. Sometimes they start at term 0. So you're starting at term 0, and then it'd be times r to the nth power. Both formulas work. It literally just depends on what you're given. My personal preference is to always use this one because as a math person, that is more accurate to me than the other one. But some of the problems that you have, because I copied some of the problems out of your book that we're going to use on our homework today. I just kind of pulled this from different places, and some of the problems came from your book, and they use a sub 0. So that's why I had to explain that one to you. So problem 6, we have a pattern 3, 15, 75, 375. Okay, what's happening every time? So my common ratio is 5. Okay, what is A1? What's my first term in this pattern? 3. That's easy enough. So then I'm going to write my recursive formula first because I think the recursive one is easier to find. So the recursive formula says to find a number in the pattern, all you have to do is multiply the one right before it, an minus 1, times our common ratio, which is 5. And that's something you guys already know. Y'all know that that's what we're doing every time we're multiplying by 5. So to find the second term, we multiply the first one by 5. To find the third term, we multiply the second one by 5. To find the fourth term, we multiply the third one by 5. Okay, then my explicit formula, it's going to be an equals, it says a1, well, what was a1 in our problem? 3 times r, which is 5, to the n minus 1 power. That's your formula. Okay, keep in mind that formulas, equations, all that stuff, they don't have, they have variables in them. You need those variables in there. Okay, because some people are trying to plug in stuff. You're going to eventually plug in things, but not right now. Like right now, we're just writing our equation that can be used to find anything we want. Then it's going to ask us for something. Which term does it ask us for? The 9th term. Okay, so could I find the 9th term by just multiplying by 5 several times? Is that a possibility? Yes. If I'm doing that, am I using the recursive sequence or am I using the explicit one? Recursive, because that's all the recursive is saying is that I just keep doing that process. But again, we're lazy and we don't want to do that process multiple times if there's a way that we can just do it one time and get the answer. So to find the 9th term, so a9 would equal 3 times 5 to the what? How'd you get 8? Yep, to the 9 minus 1, which 9 minus 1 is 8. And you can plug all that in the calculator if you want to. And it's going to give you something large. It gives you like 1 million. I think. Like 1 million something. Okay, 1 million what? 171,875. Okay. So the 9th term is 1,171,875. Okay. Good, bad, ugly, okay? Okay. It's not terrible. I don't think it's terrible because they're just plugging in stuff. Okay, look at problem 7. Same information. They just gave you a table instead of like a list of numbers. So what's A1 in this table? 243. Same thing, right? Okay, what about my common ratio? You are dividing by something. So this one's a little harder. You can't just look at it and tell. Like all the ones we've done so far, it was easy. You looked at it and you're like, oh, this is what it is. This one's a little more complicated. So if you flip back over to the front of your notes, one of the things we talked about on Friday was how you could find it. How can you find the common ratio? No. Other way around. Where you divide the second number. Yes, I need to take any term and divide it by the one right before it. So like I could take 162 and divide it by the one right before it, which was 243. Reduce that. It is 2 over 3. So that would make sense because Trinity said that we're dividing by something. Well, wouldn't if I'm multiplying by 2/3, isn't that a form of dividing? Because 2/3 is less than 1. So my common ratio in this problem would be 2/3. And it wouldn't matter which pair of terms I use. Like I could do 108 divided by 162. Or I could do 72 divided by 108. It's going to give me the same thing every time. Okay, so my recursive formula, I think that one's the easiest. So it's to find a term, you take the term right before it, and you multiply it by 2 over 3. So that's our recursive formula. For our explicit, to find any term, it says that we can multiply the first term. What was my first term? 243 by 2/3 to the n minus 1 power. And I'm going to put that 2/3 in parentheses. And those parentheses are going to matter. So in particular for this problem, what term are we looking for? The 6th term. We want the 6th term. So that means that we're going to plug in 6 for n. So to find the 6th term, I would do 243 times 2/3 to the 6 minus 1, or to the 5th power. Okay, so let's talk about how this goes in our calculator, because this matters. A lot of you just want to type this. So the problem with this is that when you type this in like this, your calculator only applies to the exponent to what it's attached to. What's it attached to in this problem? The 3, and that's it. But that's not what we want the exponent to go with. We want the exponent to go with the entire fraction. So it ends up being 32. You can also type it in. Oh, no, it's frozen. You can also type it in using your fancy fraction. Do you remember how to use your fancy fraction? Yes, alpha y equals 1. And if you type that in with like that, it's going to automatically, when you do the exponent, what's really cool, it will automatically do the parentheses for you. So either way, you should get 32. I know it's a fantastic picture. There you go. Look, it finally worked out. It just showed you what I need to show you. So the answer is 32 to that question. Okay. Yeah. All right, I want you to do question 8. All right, so for problem 8, just to make sure you're all on the same page, your first term was 3, r was 2. If it doesn't specify which equation, always write the explicit, because the explicit will find anything you want. The recursive only finds the next number, okay, which that's not always helpful to us. Explicit will find anything. So the explicit would be an equals 3 times 2 to the n minus 1 power. And like I said, you got 1536 for the 10th term in the pattern. And you could have just like continued to work it out, and you could have multiplied by 2 every time. That's okay. Again, one of the things I suggested was, if you didn't know where to start, make a table, because a lot of you were trying to tell me the first term in the pattern was 1. No, they're not telling you that. They're telling you that the first term is 3, because it's the ordered pair 1, 3. And then there's the ordered pair 2, 6. And then 3, 12. And then 4, 24. And 5, and what was the next one? 48. Okay. Let's talk about the last question. Wimbledon Ladies Singles Championship begins with 128 players. Each match, 2 players play, and only one moves to the next round. The players compete until there is one winner. How many rounds must the winner play? So for this problem, we don't actually need to write an equation. We can actually figure it out. There's a couple ways to do this. So when I'm looking at this, the question is asking me about the rounds that are played. It's not asking me about how many people are playing. So if that's what it's asking about, then to me, that's what I need to write my equation in terms of. Not that it starts off with 128 people, but in the first round, there's how many matches that occur.
64.
There'd be 64 matches. Why would there be 64 matches in the first round? Yes. So then in the second round, how many matches would be played? Okay. And in the third round, how many matches would be played? Okay, what's my common ratio in this problem? 1/2. Okay. In the fourth round, how many games would be played? And then in the fifth round? And the sixth round? And then in the seventh round? 1. So how many games would the winner end up playing? 7. So that would be our answer to this question. So again, it didn't require an equation. Okay, it didn't require an equation. It just required us to understand the process.